have, in a way, have something to do with your main descriptive, your main analysis. So let's dive into it today. I will share this screen and then we go. All right. By the way, my people, are we all in class? I have some regular people that I know for sure they should be in class. If they are not in class, I'll mention their names. When I mention your name, you just have to be in line. Okay, I can see Madam Gertrude is there, Collins is there, Madam Irene is here, Mr. Osai Tutu. Okay. And I can't see, yeah, Joan is here. Good. Maureen is here. Madam Maureen, how are you? Good. MFI is not here.
I'm fine, sir.
Okay, MFI is not here. Don't worry. We're taking note of everybody. All right, so today the question is, we hear about correlation analysis. What is correlation analysis? Someone may ask, what actually is correlation analysis? In a simple term, correlation analysis examine the strength and the direction of the association in the variable. The strength and association in the variable in a way that we actually see if A equals to B, does that mean that A is B? Or the A being equals to B, can A actually say something positive or negative about B? So correlation analysis is the strength and direction of association between two or more variables. It does not imply causation. It does not imply causality. Okay, it only shows how variables move together. It only shows how variables move together. In basic economics, we can say it's a complementary. If it's a good, we can say it's complementary goods. So how variables move together when you have your variables together, your data together, put together, how do they move together? Do they align with each other? Do they align with each other? It is not the Granger causality type. It is not Granger causality. It will show how they move. And some papers or some people or some thesis, some institution can demand that you should just perform correlation analysis. Let us see what others are saying. But sometimes we define or we explain correlation analysis to mean regression analysis. Now, so basically it is done for preliminary analysis. It's done for preliminary analysis. Correlation analysis is carried out for that. And then to detect if there's multi-collinearity in the data. If there's any multi-collinearity in the data, or describe the variable relationship, the relationship in the variable. So correlation analysis is carried out to describe, to tell, to explain, to inform the relationship within the variable. I mentioned something here called multicollinearity. Now, what is it? Basically, it's a situation in a regression analysis where explanatory variables are strongly correlated, making coefficient estimates unstable and unreliable. You see, when there is multicollinearity in the data, when the data is is collinear to each other. One thing it does is that if you perform your regression analysis and there is a presence, or there's the presence of this situation, it first, it make the coefficient estimates unstable. So the coefficients, when we get to regression analysis, we understand the coefficient. That some people call it the beta. When you when you set your model, you say alpha plus beta, alpha naught plus beta 1 plus the variable. The beta is the coefficient. So if there exists multicollinearity problem in your data, it means that the estimate is unstable and they are unreliable. We cannot rely on this your estimate to give an informed judgment. So it is very important we take a very closer look at our regression analysis. It occurs in regression model when two or more independent variables are highly correlated with each other. You see, this is it. You see, it occurs in a regression model when two or more independent variables are highly correlated with each other. Sometimes when we do correlation analysis with our data, we realize that this not correlating with the dependent variable, but the independent variable, if you have a multiple independent, or we have a lot of independent variable or explanatory variable, we see that some of them correlate with each other with a high value. So when that happens, it becomes difficult, or it makes our analysis, our decision points unreliable. So we must actually pay a very close attention to multicollinearity in our data. Meaning that it also means that they contain overlapping information. Basically, we see multicollinearity problem when we are dealing with primary data. When we're actually dealing with primary data that we send out for we send questionnaires and get the result. We mostly find this problem over there. So it means that some information are overlapping. It's always occur when you send out your questionnaire with the issue of the Likert scale questionnaire type that agree, very strongly agree, disagree. So sometimes the information can overlap, which can lead to multicollinearity in your data. I want to repeat this side. Those who deal with primary data that send out questionnaires to get data, you mostly encounter multicollinearity issue, because sometimes some of your instruments, some of your information overlaps. Okay, so it's important we take it. As a result, the model has difficulty identifying the separate effect of each independent variable on the dependent variable. Now, this is what it does. When there's multicollinearity problem in your data, the model is difficult, or find it difficult to identify separate effects of each independent variable on the dependent variable in relation with the independent variable that are highly correlated, that are highly related with a higher value. So it is very important we take a closer look at it. Now, what is this value we are relating to? If correlation between regressors, if the correlation between independent variable is more than 0.80, if the correlation between independent variable is more than 0.80, multicollinearity may be a problem. Some of you have done, who actually perform analysis already, you are now trying to move back to say, hey, have I performed any analysis that have above 80? It's more than 0.8. And you went ahead to report your dissent, and then you send it to a high quality journal, they reject your paper, you don't understand. It's because you know that you have done everything correct. Maybe it's rejected based on your explanation of it. So when you run a correlation analysis and you come across a value greater than 0 point, that you have a problem of multicollinearity. Now, one of the things that you do is that you always do is that we try to find issue, try to resolve it before we move ahead. Any question before we move ahead? Okay, let's finish the call. Why multicollinearity is a problem? Now, sometimes you see that your standard errors are very high, large standard error. I'm quite it's important that we did some descriptive analysis before coming here. Let's pay a closer look at this. Now, remember this: if you perform your descriptive analysis and you notice that your standard errors are high in your descriptive analysis by some level, you know that you definitely face it. And then another point is that insignificant T statistics, even when variables are theoretically important. Some variables are theoretically important. Some variables can be very, 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 very good. That is what theory is saying. That is what literature is saying. But if you perform and then the T statistics are insignificant, know that you face multicollinearity problem. Another thing is that unstable coefficient, signs and the magnitude change across models. So when your coefficients are unstable, they vary. The reportage are somehow, you yourself, you are not certain. Why is this? Some of us, when we try to perform our analysis, we cross-check with different analytical tools, and then before we accept some of our results. So one is that, then you know that there is a multicollinearity problem. And then difficult in interpreting individual coefficients. When there is multicollinearity, it will be difficult for you to interpret individual coefficients because it's unstable. It's unstable. Sometimes the overall model, like the F statistic, R square, adjusted R square, may still look good, but individual variables appear insignificant. Sometimes you ask yourself, why is it that this thing is insignificant? You see, you perform your analysis and you notice that your analysis, okay, the p-value is insignificant. You begin to ask yourself, why? Even though the F statistics is perfect, the R statistics is perfect, the R square is perfect, but why is it that the individual, the explanatory variable appear insignificant? It's as a result of multicollinearity. So we perform correlation analysis to ascertain, to know, or to determine, to see if there is something like that in our result. So, ladies and gentlemen, it is important we try that. Mr. Edu, are you in the class? Mr. Edu, okay, Mr. Edu is not in the class. All right, okay. All right, we continuing. So, that is it. So, we should be careful of multicollinearity in our data. I will say again here that especially those that go for primary data, they mostly encounter this. So you need to account for collinearity. You need to actually polish your data. You need to actually make your data fit for work. Your data must be fit for work. Now, Now, what correlation measures? The most common measure in STATA is the Pearson correlation analysis. Normally, we have a lot of correlation analysis, but the most common one is the Pearson correlation analysis that deal with a range. So the last time someone asked, what is the range? What should we to see that there's a problem here? I just said something here for multicollinearity issue. If correlation between regressors are greater than 0.8, then you know that you are facing multicollinearity issue. And then here, when you perform your correlation analysis, there's a range you should see. You see the range you see. The range from -1 to +1. That is the range you should see. And when it's +1, it means that perfect positive relationship. +1, perfect positive relationship. And then when it's -1, perfect negative relationship. Perfect negative relationship. Sometimes we perform our analysis, we want to see positive relationship, we want to see positive relationship, which means that we have the answers in our pocket. Sometimes some people have the results in their pocket. So when they run analysis and it didn't go with it, they say, no, the data is not correct. That is the result you have. So you have to put it in it. So when it's negative, when we have perfect negative relationship, and when it's 0, we have no linear relationship. When it's 0, it means that there's no linear relationship in the variable. Okay, I said earlier that we perform correlation to see how the variable move together, to see the relationship between the explanatory variables. The relationship between the explanatory variables. That is the main idea of performing correlation analysis. So we have a range from -1 to +1, and then +1 perfect positive, -1 perfect negative, but when it's 0, it's no linear relationship. Now, when you are running your correlation analysis, there's a rule of thumb. This one for most social science, and it's basically for everybody. There's a rule of thumb. Now, from 0.00 to 0.29 is weak relationship. Please, I want you to get this for me. When you have it from 0.00 to 0.29, it's weak relationship. The relationship between them is weak. And when you have it 0.30 to 0.49, the relationship is moderate. Okay, it's moderate. It's moderate. It's moderate. And when you have it from 0.50 to 0.69, it's strong. It's strong. Greater or equal to 0.70 is very strong. Mostly, I normally admonish people that if you have it from 0.5 to 0.69 or greater or equal to 0.70, it's very good. So when I see some correlation analysis and then they report it between the first range, like 0.0, 0.29, and they are okay, I feel that there's no proper relationship between the explanatory variables. Okay, and when there's no proper relationship between the explanatory variable, your judgment become biased. Okay, even though your judgment can be innovative, it can create innovative from it, but it's become biased. So it's good to have from the strong to the very strong, but do not have it above 80, above 0.8. When it's greater than 0.80, then there's collinearity in it. So you can see the dynamics here. The dynamics here is from this one here, from the first one here, from the third to the last one, which is very, very important for us to take look at. We should be strong in doing it. Okay, I'll pause here and see. We'll take question or contribution. Okay, Mr. Edu is now in the class now. Mr. Bright, do you have any question?
No, please don't. Everything is okay.
All right. Okay. Thank you. What about Mr. Collins?
I have a question, sir.
Okay. Okay. Come with your question, ma'am.
Okay, you've talked about when we have multicollinearity, it shows there is a problem. How do we solve it?
So there's a way to solve multicollinearity in your data. I think when we get to that place, we'll solve it. So I will note your question down. How to solve multicollinearity in our way. Boss, can I continue?
Okay, okay.
I know my boss will ask this question. Yes, any other or anything somebody want to add something to this short the discussion we are making? What you want? Okay.
But if I run the analysis, okay?
Okay.
And then I get the 0.29 or between the 0.0 and 0.29, and that is the result that I have. Is there, as you said, the person may be trying to, as it may be innovative in the interpretation. But then, is there a way we can deal with these situations? Because we already have the data with us, and that is what the data is giving. So, what do we do in this situation?
You want to see if you can just or treat the results.
Maybe so there are some variables in there. Perhaps we can take away or something. I don't know, but there's a way definitely we should deal with it so that even if we can. Those removal of some variables could move it to a moderate or something. So I don't know, maybe you are more advanced in these areas. So if there is a way that can be done, yes.
Okay. So you see, when you add water to Gary, it has an effect on it, right? Yes, obviously. There is effect on it. So it means that the water you are adding to the Gary, that's the effect you get. That's the effect you get. The relationship I'm talking about here, it is between the explanatory variables. So if that is what is giving you, that is the result. I am not saying that if you have that, you should try to do something, you should do something about it. But when there's multicollinearity, that is where you have to take a closer look at your data. But with that, it is okay.
Okay.
It's okay. It's okay. You don't. I want to admonish here. Sometimes we run our correlation analysis and we want to force the result to get to a strong and very strong. You want to force the result. Then that becomes academic dishonesty. Some journals can request your data. So when they send your data to you, when you send your data to them, we will not be there to explain why you push it there. So when it's within the week one, it's the week one. Report it and go ahead with your analysis and then interpret your result to form your novelty in it. Mr. Collins, are you okay?
Yes, I'm okay because, for instance, some reviewer like you, perhaps, I don't know, because you said that sometimes when you receive a paper that report, maybe a weaker, and so it raises a question as to whether that is what the person has found. So if that would make the paper to be seen in a way by a reviewer who has their own personal judgment, it becomes some level of a problem. That's why I'm asking that question.
I made that statement for you to know that, you see, you can have if you have the weak one and you report that it's weak, but in your regression analysis, your result is different. in conjunction with your correlation analysis, then you raise questions.
A lot of questions. Of course,
Yes.
yes.
So my straight point here is that when you have the week, your result should have something similar to that. But when you have something more than that, it raises a lot of question marks.
Yeah.
So we are also learning in that direction. Yeah. Anybody else? Anybody else? That is the point.
Hello.
Right? Yes, sir. Please come.
Yeah. Okay, sir. So with respect to what Mr. Collins just asked, when reviewers see this report, don't they reject your work, thinking that maybe you didn't get a good correlation based on the weak or the moderate results that you report?
Well, in my case, I would not reject your work, but instead, I'll request for your data. And then in the request of your data, I will ask you to add a sentence, the command you use, so that I can also enter the command like that. You see? You get it?
Yes.
Maybe I will look at it, and then, but the point at which the result will reject, your paper will be rejected, or you can reject, or I can reject your paper, is that when I see your final explanatory, the regression analysis, or if it is a structure equation model you perform, whatever you perform, when I see that, just opposing with that, you definitely that you've cooked the results. You remember, if you don't know, some people recently or last year, some papers were withdrawn from Springer Journal, right? Yes, some papers, it's online. It's not because of anything, because they report a wrong result. The data they use, it's saying different thing. You see, which I don't. The paper was already published, but again recalled off from online, which raised a whole lot of things. So my advice here is that let's get the right thing. Let's do the right thing. If your result, your data say 0, let it be 0. Any question or any other?
Yeah, so I'm kind of confused here. I just want to know, in this situation, which ring should you be more comfortable with? Is it the moderate or the weak? Because it seems you are not safe irrespective of the range that you fall. Your data falls.
I would admonish here that if your correlation analysis fall between from the strong and very strong, right? The moderate should not, if the moderate is coming, it should lie from 0.49. That should be the moderate. But please, ladies and gentlemen, don't force it to get there. Okay? Don't force it to get there. Are we together?
Yes, please.
Yeah, don't force it together. Don't force it together. Mr. Johnson is in the class, right?
Yes, please. He's in the class.
He's observing us. Then you come up with some strong. Mr. Johnson, do you have anything to add?
Yeah, exactly on point. But I would like to add that if we are to look at the correlation, we can also look at the variance inflection factor or the tolerance level of the variables.
Yeah.
Which will add to the correlations. But everything you are saying, 100%, boss. Salute.
This man will kill me. Let's continue. Thank you, Mr. Johnson. Thank you, Mr. Johnson. So it is very important we have to take a very close. Actually, writing analysis, it's the data. The data. Don't sit in your room. Draw a table. Draw a table and begin to add 1 plus 1 is equal to 2. 2 plus 4 is equal to 6. 0.0421, 0.5921. That is not right. That is not academically right. It's dishonesty. Let's do the right thing. Get the data, run it, the result, let it come. I read the paper. The results are very, 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 very annoying, but it tends to be a very good paper. The results are annoying, but it tends to be a very good paper. So may we be guided. Now, let's continue here. Now, in STATA, you can create some. These are some of the commands to get the correlation analysis, the Pearson correlation, PWCORR. When you type into the command, it will give the correlation analysis on the data in the system for you. And then if you want to display a significant value or value to it, just SIN, enter, it will display. Okay. If you want to add star of significant at 5%, star into bracket 5. See, these are the commands when you get to the correlation analysis. There are some correlation analysis that are used basically. So you see, I was talking about people with primary data. I was talking about that. You see this type of correlation analysis. Spearman rank correlation analysis for normal data. Some data are not normal. Okay, some data are especially raw data. Raw data. Sometimes you can get the data from the secondary source, raw. Okay, raw data from secondary source, and then before you realize you want to perform analysis with it. The Pearson correlation might not be appropriate, might not be ideal. So the Spearman rank correlation can be very, very important. You use it when the data are not normally distributed. When the data is not normally distributed, variables are ordinary, outliers are present. So this is the basic side of correlation analysis. Okay, so I will pause on the tutorial, the PPT here, and then we go and perform a correlation analysis in the system. Ladies and gentlemen, the attender, I think the attender is shared. Mr. Kojo, that is attendance, right?
Yes, Doc.
Okay, so the attendant is shared, so you can scan and then you do it. You do the attendant. Madam Joanne, do you have any question?
No, please.
Okay. Then who is Madam Sharon?
Okay.
Madam Sharon, do you have any question?
No, please.
Okay. Are you following anyway?
Yes, I am.
Okay. Madam Linda.
Please, there's no question here.
Oh, okay. All right. Thank you very much for being in the class.
Hello, sir.
Yes, sir. Please come, Mr. Du.
Please, I don't have a question, but I have a request. I mixed the first 20 minutes of the class, so I would request you share the PPT so that.
All right. What I'm doing is that I'm compiling all the PPT and then I will share. Or I don't want to be sending it one by one.
One. Oh,
so,
okay.
Yes, I'm compiling all the PPT and then I will share it.
Right. That's good of you. Thank you very much.
What's up, Mr. Adam Salifu?
Yeah, I'm following and I don't have any question. Thank you.
All right. Thank you too.
You're welcome.
All right. So let's
okay. I just want to thank you for explaining this multicollinearity so well for me to understand. I actually struggled with it with my supervisor, and his English is not that good, so he found it very difficult to get me to understand it. But here, I got it so well, and I thank you.
Thank you very much.
You're
Thank you
welcome.
very much. Oh,
I think same here. I've been trying to really understand this whole multicollinearity thing, but I think today I've realized that okay, this is how it's supposed to be.
Yeah, so clear now.
I think we should close the class. If 2 people have already gotten the class, we should close the class. What do you think, Mr. Johnson? All right.
Dr. K, I think that would be unfair on the part of those who may not have the basic understanding of what you are teaching. That being said, I think you're doing a good job.
All right. That's okay. That's okay. So we will just perform a simple regression analysis here, multi-correlation correlation analysis here, and then we'll see how we can do this. Now, please go ahead and launch your stata, and then you call your data into the system. Let me first clear my okay, so okay, so if you already launched your this thing, please do call in your data. So as usual, I want my screen to show us. All right, so as usual, we go to File, Import, Excel, and then we call our data. So our data is working. I should think so. Okay. Now, we have our data in the system. Okay, I'm trying the other times. All right. So our data is in the system already. Let's go straight. I said we can perform the correlation analysis by just typing the PC, right? Let's try the command and see. Are we together? So PW CORR. You just type it and you enter. PW CORR. So that is the typing at the command base. Typing at command base. You see, typing at command base. But if you want to perform it in a special way, you can just go straight to the statistics. Now, basically, you can see this result here. And you can see that obviously there is a level of multicollinearity in between some of the variables. Between some of the variables. Okay, there's between some of the variables. But basically, we look at the explanatory variables. Basically, we look at the explanatory variable. You see, we can see some multicollinearity issue here. One is also here. One is here. Okay, that is here. But let's do it in a different way. Let's go to statistics. Okay, we go to summary. Summary statistics. Move to summary and descriptive statistics. Come down to correlation and covariance, right? Let's try the first one. Let's try the first one. We call in the variables. Now, we want to call from TFP, GDP growth, export, import, net export, inflation, education. Let's try this once. Let's only try this one. And then we submit. Okay, we submit. Now, from this analysis we've just seen, you can see, as I explained here, that it occurs as a multicollinearity situation in the regression analysis where explanatory variables are strongly correlated. Explanatory variables are strongly correlated. Or it occurs in a regression model when two or more independent variables are highly correlated with each other. You see, so having that at the back of your mind, with this regression analysis, the correlation analysis we just performed, we are performing it with zero significance. We are not checking whether the relationship is significant or not. We are just checking if it is okay. Now, what we can see here, normally correlation analysis, the variable can correlate with each other at 100%. You see, so that's why you see TFP correlating with TFP at full 1.0000. The growth GDP also correlates with GDP growth, the same thing. So diagonally, it flows like that, which means that the variable is okay. But we go down, let's try to see exports with GDP growth. Export correlating with GDP growth at what? 0.4610. Now, with this, can we say that it is moderate, strong, or whatever? Here we can see that per the judgment here, you see 0.03 to 0.49 is moderate. You see, and then the results here also saying that is 0.46, which is moderate. It's moderate. So we accept this result. We accept this result. Okay, but now let's look at something that is very low. I'm dealing with the correlation between the explanatory variables. Now, and when you see imports with GDP growth too, is 4 point this, which is also okay. You see, and then but when you see net export with GDP growth, what do we see? Is negative this, which is negatively perfect or perfectly negative relationship here. Okay, so let me ask, Madam Joanne. So this here, negative 0.3619. What is it, moderate or weak?
This is moderate.
It's moderate. So the result is that we can go ahead to perform, right? Good. And from what we just also saw, it's negatively perfect. There's a negative perfect relationship here. The same thing here. But now, when you go to import to export, it's 0.9202. Mr. Collins, what do you think is happening here?
It suggests that there's some level of multicollinearity between the two variables, or there is no difference between them.
Good. This suggests that there is a multicollinearity issue here. Now, there's something I forgot to discuss when we were talking about the multicollinearity. Sometimes there are some variables. There are some variables. It doesn't matter what you do to them. Some secondary data, there are some variables. It doesn't matter what you do to them. There will be collinearity in them. One of them is this import and export issue. Import and export issue. I've been running analysis for years. I always come across when I'm trying to find something in relation with import export, there's always coloniality issue in it. In Africa particularly, there's always issue of multicoloniality, which is not a result of anybody. It's a result of human relationship. The rational human being. So this one is related to the rational human being issue here. Okay. Now, so we can see that this is all, there's a problem here. There's a problem here. And then we can also see, you see, from infrastructure here to export, it's very strong, right? Very strong. And then we see this, it's quite okay. Quite okay. So except the multicollinearity that we have here, which is an issue which we need to work on, but this is perfect. It is actually perfect. But when you are running some and you come across some things like this, you should actually also check what literature is saying about them. Let me add this. When you notice that there's multicollinearity between some variable, sometimes it's not about just working on it. It's about also pausing to read literature around it. You can also read literature around it to see. Okay. Now, before let's continue again. Let's continue. Now, sometimes we can run this regression correlation analysis and trying to see if the relationship is significant. The way they move, the way variable A move with variable B, if their movement, there's kind of something good to write home about. Let's perform that by going straight to. I said, so we need to give a better command here. So let's go back to the statistics here. Please, are we following, by the way? And are we also running it?
Yes, please.
All right. Now, this is also another regression analysis, correlation analysis. And then we call in the variables. Again, I'll start with this as usual. Then I call the variables. Okay. Now, you can see that this window that open, it says a print number of observation for each entry. It's a print number of observation for each entry. Print significance level for each entry. You see? And then you can, here, you can significant level for displaying coefficient. You can adjust it here yourself, here, or you can leave it. But first of all, let's try it first by printing significant level. Okay, click the print significant level for each variable. Let's submit it and see. Now, we can see additional information with this correlation analysis. There's additional information here. Now, the same point exports correlating with GDP growth, it's same 4.0 point this, and then it's giving a significant level here. So we can report our correlation analysis and then add significant level to it, which is very, very important. When you are dealing with data, you are running data, you are running these things, it's very, very important to also add significant level to this. That inform the reader, that inform your audience. So your descriptive statistics, we extra statistics like the variance, skewness, ketosis, it's important. And then when you're performing your correlation analysis, it is also important to add extra the significant level to it. That will make it become more attractive to read. It attracts people to read. Now you see, yes. Now you see, when I said earlier that you might have your results okay, but see, it is above normal. There's multicollinearity here, but it still was significant. Multicollinearity by significant. Then you got, this is where you have to go back to read your literature, to read another literature. But why is it that there's multicollinearity? Why this is significant? The relationship is significant. It's going hand in hand. It really go hand in hand. I'm talking on the part of this import and exports here. It goes hand in hand. Significant is okay. But there's multicollinearity. All right. Any question before we continue? Someone asked about how to correct multicollinearity. Please, any question before we continue?
Yes, I have a question.
Yes, please, come, sir.
Yes, please. When we're going through the PPT, we made us understand that when the correlation coefficient, or when the value is between, if it's above 0.8, that means that among the regressors, that means that multicollinearity may be present. But here it's like when we are seeing the result, you are very emphatic that the multicollinearity is there. Is it that maybe, is it a probability, is an assumption that it may be present, or it is a confirmation when the value is more than 0.8? So that's what I want to ask. Okay, is it a suggestive, or is a definite?
Okay, so let's go back to the PPT here. Okay. That's Mr. Molly, right?
Yes, please.
Molly. It said if correlation between regressors is greater than this may be a problem. We pre-suggest that there is a problem of multicollinearity. So you can also, wisdom is big. We can also check with literature. Okay, but from where I'm sitting, when you have something greater than this, there is a problem of multicollinearity between those two variables. Are we together?
Okay, so that means is when it's above, it's just telling us it is there. So it's not maybe, it is definite.
Exactly.
Okay. Because you say maybe problem, so maybe that is why I would know. Thank you.
Okay. Now, there is one way we can correct this multicollinearity here. Now, they say that, or it is said, or literature proved that to correct multicollinearity, drop one of the correlated variables. Number one, when there's a problem of multicollinearity, drop one of the correlated variables. Drop one. 2, combine variable into an index. Okay. Combine the variable to an index. Let's try the first one. They say drop one of the correlated variable. Okay. Now, let's see if it works. Then we can confirm. We are together, right?
Yes, please.
All right. So, I still have my displayed here. Let me drop import. Let me drop import and check. Now, when I drop the imports, obviously, there will not be problem over there. But is that what the thing is saying? No. You see, drop one of them. Let's go back and still perform our analysis again. Now, we still have our imports. Let's drop education and see. Let's submit. When we drop education, what do we still have? There is still a problem of multicollinearity here. Okay, but when we drop first the import, that problem is solved from that angle. Okay, that problem is solved from that angle. So it pre-suggests that with multicollinearity in it, I will again say it here, that there are some, especially when you are using secondary data, there are some you cannot avoid multicollinearity. There are some data that some indicators you cannot. But when you have a problem with primary data, then you should also go ahead to check your instrument. Check instrument. So another problem of resolving multicollinearity is that rely on theory to choose the most relevant variable. I'll say here, when you have problem of multicollinearity in it, now we need to go back to theory and look at the variable that can actually match with that problem. And then when we bring it, we call it off. You saw that when I call off the export, okay, Now, let me call up the import and include a different variable. Let me include a different variable. Let's say I include health and I submit. You see, a health with GDP growth, there is nothing like that. Health with export, there is nothing like that. Health with health with GDP growth, health with export, there's no problem like that. So you see, when we rely on theory, we can solve the problem of multicollinearity with secondary data. But when you are doing with primary data, then you have to first of all, check your instrument. Check your data collection instrument. Or check the information you provide. Some of the information overlaps, then definitely there will be correlation, multicollinearity problem. Okay, so gentlemen, ladies, we should also be careful the information we feed into the system. Yes, any question or contribution, please? So the one that asks for, okay, here is Madam Maureen. Madam Maureen, the problem to solve it is one, drop one of the correlated or the correlated variable. Two, rely on theory to check. Three, combine the variables into index. Or you can use there's a analysis called principal components. I think there's an analysis you can use, that principle of component analysis. Principle of component analysis. PCA. Yes. Yes. You can use PCA to correct multicollinearity. Amen. Hey, I say amen. Thank you. I mean, someone, please, you can ask your question.
All right. Please, you see, in this example, we use GDP in relation to export. But in case you want to use TFP and you infrastructure to TFP also gives 0.8274. Does the same principle apply here? Because since it's 0.824, then we can see the issue of multicollinearity here.
So at this point, what do? We rely on theory to see if we can actually use infrastructure for TFP.
Okay.
And then basically, sometimes I would also admonish that when you rely on theory, let's go back to literature too. There are a lot of literature. The giants are there. Let's stand on their shoulder. All right, Mr. Gojo.
Hello, Doc.
Yes, sir.
Okay. So with looking at the three examples you demonstrated, what I was seeing is that means import and export are overlapping.
Overlapping.
Because I could see that when you remove either import or export, it works. But when the two are in it, we still have the multicollinearity in it. So the question I want to ask is that in this case, if you are going to write a paper or your thesis, is it good to first get your variables and run the analysis first, or you can start, because a situation whereby you are done with the literature, everything, and you go and run the analysis and you are having issues? In this case, how would you advise someone who wants to write a paper or a thesis?
Okay. I want to give you an honest example, a very honest example. Professor Gonzalez at Aberdeen University, Scotland. I told him, Prof, I don't know if he said, when I presented my topic, he said, what's your data? I said, I'll use secondary data. Okay. Then he paid for the secondary data for me from World Bank. The one we normally download, sometimes there are problems over there. So when you get a paid one, it's okay. So he downloaded the data for me and said, yes, put your variables, pick the data for your variable, run the analysis. And then I realized that there was multicollinearity in it for me. And I told him that there's multicollinearity. It's okay. Then choose for yourself. So my advice here is that sometimes it's advisable to get your data. Sometimes it's advisable to get your data. But it is also very dangerous. After getting your data, you run it, and then the thing is different. What you want to solve, you might not continue the research. So I would suggest here that if you want to write your paper, first of all, get your data, get your variable, test your data, test your variable before you pick your topic. But if it is a call for paper, here, if it's a call for paper on a team, report the results as it is. Are we clear? Let me come back. Let me come back on this. Please get your data, get your variable, test it, test your analysis. You have your methodology, test your analysis, okay, before you proceed. But if the paper you want to write is a call for paper on a team, please, on a team, please report your results as it is. But it's very, very important that you have your data before you continue. Sometimes when you want to write your paper, first of all, I think the most important thing you should do is develop your literature and get your data before you go to your introduction. Okay, so I think here you need to get your data, test it before you proceed. Mr. Kojo, before I go back to Molly.
Yes, it's correct.
All right. So Molly, I see your hand up.
Yes, please. When you are giving out the diagnostics procedures, when we tried them, you see, when we are having a multicollinearity between export and import, we drop the import and it works. But subsequently, when we are running another one, you made us drop education. But education has no any multicollinearity in the model, but you will drop education and we run again. It's just that you just want to demonstrate to us, or it's just there's a basis. Is that?
It's a demonstration.
Okay. Now, secondly, you said we should convert the multicollinearity variable into index or any other variable based on literature.
Yes,
which other variable do we convert to index? The
combine,
yeah, combine the coordinated variables, right?
Yes, please.
Okay, then that is okay. Thanks.
Or you can use the PCA.
PCA, yeah, okay, principal, okay. Most grateful.
Yes, you're welcome. Madam Mori, please.
I have a question.
Please
I have a question on combining. How do I do that? Like combining variable into an index.
Madam Mori.
You're laughing at me. I have to be frank. I'm here to learn.
Yes. Mr. Johnson, can you help us?
Please, if she could repeat the question.
How do we combine the variable into index? Her question
thank
is...
you. Thank you. I think with combining the variables into an index, we have two ways, basically two ways. We have the mean approach or the sum approach. For instance, our import and export are highly related. So we take the sum divided by the number, that's 2. That's the first approach. The second approach, we use the mean approach, which we take the we take the mean of the two variables into account. So we add the mean of the two variables into account for each row to get another row.
Okay.
Thank you.
So I'll also add to it here that one of the way to combine, as he rightly put, I will also point out here that in trying to combine it, you should also be careful. If the variables are on similar scale or conceptually equally important, right? You can combine them if they are on similar scale. If they are not on similar scale, it will be very difficult for you to combine. As he said, you can the mean of the two variables. Okay, the mean of the two variables. So let's say like 1, 2, variable 1 and variable 2, right? You should actually check if they're actually, if it's possible to combine them, right? And if it's accepted in economic analysis or in your field in business analysis. If not, you can't just combine it. You should also rely on theory to combine it. Okay. All right. I see Mr. Bright, your hand is up.
Hello, Doc. Yeah.
Yes, sir.
Please, I would also like to add something to the combination. Okay. Sometimes some of the numbers are really huge. So when you sum them, you get highly huge numbers. So sometimes you can use the log format so that you know the percentage relationship with the various variables. And as well to talking about the indexing. For example, data that I worked on, I needed import, I needed export. So you can represent the variables with trade. So you first do the analysis with export, then you say that maybe, okay, with trade between Ghana and China, based on export, this is the result. Then you also use the import to do analysis. So trade between Ghana and China with import, this is the result. So sometimes you can use that as the indexing and representation of variables when you have a multicollinearity problem. Thank you very much.
You're welcome. They are scholars. This is Mr. Bright, Scholar Bright take on this one. Maureen, please, are you okay?
I'm not okay. So
I like that. You're not okay.
Yes, I want to a more illustration. Like you say that I can go like check on the means. Do I check the means and then I come again run the correlation analysis, or that will be enough after checking the means?
After checking the means, will you come back to run? Yeah, the goal is that after combining it, then you rerun.
Yes, I wish you could do an example so that we can get it right.
Madam Maureen, you want us to? I think that's laudable, right? But with my data here, okay, unless I call in a different data, with my data here, this multicollinearity you are seeing here, to me, it's good for me. So I don't know if I change it. Mr. Johnson, is there any suggestion?
Well, I think with what she's saying, it's good to do. And with that,
okay.
just like necessarily, sometimes not necessarily combine. There are various with their various literature there, but you know, some of them are how do I say this? The nature of the class is limited to some of the approaches. You know, some of the approaches are heavily mathematical.
Yes.
So you have to introduce a lot of things, which
Yes.
we
So
are aware. And also like to add that with is it Mr. Bright or his suggestion is also good. She can try that one. It's also helpful. But I think I did
yes.
that
So
recently with a particular paper in econometrics. So
okay.
I believe that approach is also best. Thank you.
Madam Maureen, I think we'll get back to the correction for you to do the proper things for you. Is that okay?
It's okay. Okay, sir.
Thank you. So I'm writing it down so that you can, I know you call me to remind me, I know.
Yeah, Doc, I was even going to say that.
You have to do that.
Yes, sir, please.
Yeah, I was going to say that if the data you have now, if you make any changes, it will distort it. We can reorganize, and probably in our next session, you can get a good data which can actually help us with the demonstration.
Exactly. That was what I was also looking for. That was what I was also looking for. Because if I touch this thing, even though I will generate and store it, but thank you very much. Thank you very much. All right, before we end the class, before we end our class, we need to perform a simple regression analysis. But any question on the correlation analysis? Please, this particular one is also important. Correlation analysis is also important. It's important in our paper writing, in our thesis, whatever we are doing. So I want us to be clear on it before we move ahead. Any question or any other question or contribution?
Yeah, I want to ask. I don't know whether it's a question or it's a suggestion, but let me ask a question. So it means that sometimes maybe we could have some presence, or there's a presence of multicollinearity.
Yes,
however, maybe in the main regression analysis, it hasn't brought any problem. And we also have a literature or theory basis to defend it, and so we can leave it as such. Is that the scenario I'm trying to get?
So
for instance, maybe it's just, I could say it's negligible, maybe 0.82. And then if we use the data to run the regression analysis afterwards, it hasn't caused any problem in the regression analysis. So in that case, can we maintain that 0.82 if we have a literature base or a theoretical basis to defend it?
Yes. I get you. Everything is about how you defend it, right? And the support, evidence to support it. If the evidence to support it, fine. If there's no evidence to support it, then you leave it, and then that become an evidence for somebody.
Yeah. Okay.
Thank you. For somebody. Yeah. Any other? Okay. So key thing, it is important to check correlation in the variable. You'll be surprised that some international journals, you will not see any other analysis in it apart from the correlation analysis. And the paper is online, it's published. Okay. I think you can also get those papers to actually support your findings. Also get it to support your findings. All right, so let's just perform a simple regression analysis. Simple regression analysis. You can perform it with the statistics here, right? The variables are here. Linear model, linear regression. All these are also here. But you can type a command, but say reg, regret. Okay, regret. And then mostly we regret the independent variables on the dependent variable. Okay. To avoid typographical error, typing error, right? You can just easily go back, call in the variables you are working on. Call in the variables you are working on. And then you hit enter. You hit enter. And then you have your work. Now, from the regression output here, you see it's a regression, total factor productivity, export, import, net export. Okay, export, import, net export. All right. And then here we have source. We have model, residual, and total. SSD, different degree of freedom, MS, number of observation, this F2 and F42 of 32.56. That probability F of 0.0000. Good. We have R square 0.6220, adjusted R square 0.6040, and then root MS is what? 0.1435. Now, and then we have the main effect here, the main impact here. Now, let's look at this whole thing. Somebody is asking, what is residual? What is model? What is R square? What is adjusted R square? What is probability F? What is this? Mr. Collins, can you tell us your understanding of R square? Mr. Collins, you are
the R square is the percentage of variance that the independent variable has explained in the dependent variables. Yeah, that's
okay. Mr. Edu, any take on that?
No, sir.
I had variance. I don't understand the variance. That's why I'm asking you, senior.
Okay, so
Madam Joan after you. Yes, please, sir. So, Mr. Edu, I'm listening.
okay, so you are talking about the R square, right?
Yes.
Which is 0.6. Let Mr. Johnson come in, sir.
I want to try.
You want to try? Sir, try,
Yes.
sir. Try,
Okay,
sir.
yes. So R square is basically telling us that the changes in the total factor productivity that is being explained by the variable that we use, that is export, import, net export. So basically what it means is that the contribution of all these variables to the total factor productivity. So the changes, basically changes in total factor productivity that is being explained by the input or the independent variables is what the R square is reporting. So here is in a layman's point of view, just that the 62% of the changes in the total factor productivity is being explained by the three variables that we have used: export, import, and net export. So that is what I'll have to say. I don't know whether you get me.
Yeah, yes, sir. Yes, sir, I get you. Yes, sir, I get you. Okay. Now, let's take it one after the other. And now, Mr. Johnson, you want to help us?
I think that's exactly what as our friend or doc said. Just like the changes The total change that is explained in TFP by the explanatory variables.
Okay.
Yeah, that's the total change. Yeah.
Okay. Okay.
I think that's okay.
Which also we can also say here, all that they are saying is true, is perfect. It means that any decision that we will make or any decision that we will take in line with the explanatory variable is at 62% correct. Which means that the variation, the changes, or all that happened to a TFP with all the variable is 62%. Now the question that posed, why is it not 100%? Why is it not 100%?
Yes, basically it's not 100% because it's telling us that there are other variables that can also influence the total factor productivity.
Which means there is a stochastic in the model.
Yes.
Good. That's very good. That's very good. Today the mathematicians and the econometricians are in the class. Madam Joanne, are you in the class?
Yes, please. I'm in
You
the
see
class.
you see the way the mathematicians and the econometricians are dealing with us in the class today. We just
Yes,
follow
sir.
them. Let them teach us. Let's go. So sometimes I come across some colleagues that say that our R square is very low, so the paper they can't continue. Who say you should not continue the paper? Who says you should not continue the paper? Some people even got 0.004 for the R square, and then the adjusted R square. It is good. That is what it's saying. That is what they say that. That is why it is called explanatory variable. They are explaining the changes that occur. Let's take, for example, you say, yeah, let's make this example. Ladies begin to grow. And then at a point in time, they say they've entered something called menopause. The things that contributed to the changes in the menopause are the explanatory variable. And one of them is up to 62%. So the changes in it. Now, when we come to adjusted R square, why these two are very important in our analysis is that these two are very important in our analysis. We can make a decision that the correct R square is this, but when the variable or the model is adjusted, it brought another equation or another change. The change now is what? 0.6040. Okay, so even with the changes, with the adjustment in the model, we still have this. So when you run your analysis, it is important to take a closer look at this. So the R square tells you the variation in the model. Adjusted R square tells you all the adjusted variation in the model. Okay. Now, we have something called residual. Residual simply means the variation not explained. We have the variation explained to be 0.620. And then we have residual. Residual in the model means that the variation that is not explained, the error term. So you see, when you write your model, you write, and then you get to the last one, you write mu at a particular time different, or error at a particular time different. So the residual is the error, the variation not explained. Okay, the error term, the variation not explained. So those who do structural equation modeling, when you plot your or those who do smart TLS, when you plot it, you see that you get your variable and then another variable to the latent variable, another small variable somewhere. That is the error term, the variation not explained. So when you run your regression, you run analysis, you will see, yes, the residual, there's R squared, residual and R squared. So which tells you that this is the error term. This is the error term. So the variation not explained. Now, you have also another thing here. We have a F statistics, F here, F this one. Let me call, today that I have a lot of econometricians in the class. Who should I call? The NUGS-CHINA host. Should I call you Mr. NUGS-CHINA or Madam NUGS-CHINA? NUGS-CHINA. Madam Getty, are you with us? Madam Gertrude. Okay, let's go to Mr. Edu. When you run your analysis, you see F this. What does it imply? What does it mean?
If I'm right, it's about the number of variables. Yeah.
Okay. All right. Mr. Collins, anything?
Yeah, it's the number of variables, but usually we look at it as the degree of freedom. The first two probably is for, I don't know how I'm going to put it, but it caters for the variables used in the model. I don't know, but and then the 42 more or less like for the residual or something. Then that is the value.
Okay.
So,
okay. All right. This F check whether the independent variable jointly explain the dependent variable.
No.
Rightly explain whether the independent jointly explain the dependent variable. I don't know what is happening to my other screen. It's going off. But please, can I be heard?
Yes, please. But just that we cannot see your screen.
Yes, I don't know what is happening to the other screen. Okay.
Doc,
Sir.
Permit me to come in.
Come in, sir.
Thank you. When we talk about the F statistics, it tells whether the model is valid or if the fitness or the fitness of the model. It speaks about the fitness of the model.
Goodness or fit of the model.
We look at it with goodness and fit of the model. So if basically when we compare with the F calculated, that is when we make the decision.
Yes.
Or we compare with the p-value, and then we make the decision. Thank you. So actually, it talks about the goodness of fit of the model.
Yes.
Just like the R square, which talks about 62% of the times the model will be useful. Meaning that if you are to predict with the model, its prediction accuracy is only 62%.
Okay.
Thank you.
Thank you. That's it. So the prediction or the decision point is 62%. The decision point is 2%, or the forecast point is 62% of the model. That is, my people, the other screen is off, but I wanted to, I believe yes, this is very good to know. Please, if you run your analysis or your laptop. Okay.
Yes, please.
So we can again agree here that the R square is very, very important for us to have in the analysis, and then the F statistics to have in the analysis. Now, degree of freedom here is 2, comma, degree of freedom here in the model is 2, and the residual show 42. Okay, and then number of observation equals to 45. Number of observation equals to 45. But shouldn't the degree of freedom and the number of observation put together to be the same? You can see, sorry?
Please kindly repeat
shouldn't the degree of freedom, it's a question to the class, shouldn't the degree of freedom, right, where we have 2 and then we have 42, and the number of observation is 45. Shouldn't this be the same?
Normally, the degree of freedom is -1. So it will not be the same.
It will not be the same, okay.
Yeah.
The degree of freedom is normally -1, so it will not be the same. Okay. Now, why I asked you this, why I asked the question was that I saw some papers, right, trying to juxtapose or trying to force the degree of freedom to be at a level. They are forcing the degree of freedom to be at a level, which I would advise that if you are writing a paper, do not try to do that. Some reviewers will calculate, will even tell that no, this is wrong. And it will lead to the rejection of your result. So I would say that when you run your result, please let the result show like that. Let the result show like that. Okay. Yes, our time is up. Our time is up. My concern today is on these 2 things. The degree of freedom, my concern today is on this, the first half of the result. So I'll pause here, and then we can call it a night. And then please, it's very important that we also take note on our correlation analysis and the rest. Thank you, ladies and gentlemen. Any question, contribution?
I think the last time we were talking about transforming the negative values, which I want to add that the command about it is, I don't know if I should type the command there, but I think you can help with that so that it's easier for all of us.
You can do that, Mr. Johnson. Can do that.
Oh, your screen is not coming. I would have asked that you demonstrate it for us to see.
Yes, my screen is not coming. It's really not coming.
Or better still, can we do it at the next meeting?
Yes, please. Please, when we start the next class, please quickly, someone to quickly alert me so that we'll do that before we continue. continue.
Hello, sir.
Yes, please, ma'am.
So we have done regression analysis. So should I, like, after doing the regression analysis, it's like I've seen that it's all about goodness of fit.
That's the first part. The first part. That stop at total. That's the first part. We've not explained down the what the
Okay,
table.
so then we are going to explain next the root MSC.
Yes, please.
Okay, thank you.
So we will explain all this when we meet the next meeting, because the next meeting we are going to actually base on this regression analysis, and then we'll start building on the rest.
Hello, sir.
Yes, please come, Mr. Salifan.
Thank you so much. And I would like to find out whether in our next meeting we will have a demonstration of the PCA.
Okay.
About a year ago, I had an encounter with it. I didn't know how to go about it. Someone had to help me, but I'll not be able to do it on my own again. I want to find out if in our next meeting we can go through that.
Okay, so next meeting we have transforming of data, the log, and then the PCA.
Yes.
Okay.
I had 3 ICT variables, and I was asked to put all of them together into one variable, ICT development. So I actually could not do it, and then someone had to help me to perform the PCA. But I don't think I got it.
Okay. All right.
All right. Thank you.
Okay, ladies and gentlemen, we call it a night. Please do have a good evening.
Likewise, sir.
Thank you.
Thank you.
Thank you too.
It was great.